Hi everyone. In today's video, we are going to work on how we can check missing values, how we can select variables, how we can convert the variables to vector variables, and then the application of logistic regression, their results interpretation, and how we can calculate the odds ratios in RStudio. So please open your RStudio. Go to your R. So for example, this is my R script file. So you can go to file and then open file. If you have already script with file in your working directory, if you do not have that one, you can start a new file like a script file. All right, so if you're not sure about the introduction of the interface of RStudio, please watch my earlier videos. Okay, so we have already done one video on simple linear and multiple linear regressions. If you are not sure, please watch my early videos. And this time we are going to work on how we can apply binary logic model or logistic regression in RStudio. So first of all, let's set your working directory. So this is my working directory. So if you are not sure how to set working directory, please watch my earlier videos. So this is how you can set working directories. And then load these two packages, dplyr and tidylog for data wrangling. Just hitting Control Enter. And then for data, in today's data, we are going to take an example from Titanic data. So for that, please install package Titanic by install.packages command and run this one by hitting Control Enter. And then because I have already run this package, so that's why I don't need to run it again. And then load this package by library command. And then this data underscore train is the data we want to use for today's exercise. Please run this command. And there we go. So you have this data. If you click on this one, so in this data, there are total 891 observations and 12 variables. So let's click on the data to have a look on the data. So first variable says passenger ID, then survived, then passenger class, name, sex, age, siblings, parts, ticket, fare, cabin, and embarked. These are the name of the variables we have. So let's check the structure of the data by hitting this command str Titanic test. So so we have Titanic train data. So by hitting this command structure, so you will be able to see the structure of the data. All right, so sex, age, sibling, parts, ticket, fare, cabin, these are the names of the variables. Let's check how many missing values do you have in each variable, especially the variables you are interested in. So for example, I'm interested in survived. So let me see the data again. So I'm interested in this variable survived, and then passenger class. I'm not interested in names for today's exercise. I'm interested in gender variable, then age variable, sibling variable, not interested in parts variable, not interested in ticket variable, and interested in fare variable. So let's check how many missing values do you have in survived variable. So the command is sum, then in the bracket is.na. So it means that is there NA? NA means not available. Is there NA in Titanic train data $survived column in this data and in this column? Is there any NA? So run this command by hitting Control Enter. So it says 0. So there is 0 missing value. It means this variable is complete variable, or it has all the observations. Similarly, check the other variables. P class, 0 missing value, sex, 0 missing value, age, 117 missing value. How to deal with the missing values, I will record another video that how we can deal with the missing values, and if we want to replace the missing value with something like mean or some we use some sort of imputation method, we can. I'll make another video on this one. Okay, so similarly check any missing value in sibling variable. So zero sibling value, zero missing value in sibling, and similarly in fair, zero missing value in fair, and then cabin, zero missing value in cabin. All right, so I'm interested in, as I said, I'm interested in survived variable, p-class variable, sex variable, sibling variable, fair, and cabin variable. I have dropped this age variables because it includes the missing values. I will make, as I said, another video how we can deal with the missing values. All right, so then select from Titanic train variable, Titanic train data, these variables, only these variables, and then drop all other variables. Okay, the command is mydf. Mydf is the name of the data you want to select. You want to name your new data, then select train. Titanic train is the name of the data. Then these are the name of the variables. Let's run this command by hitting Control Enter. See, new data is created with 6 variables. And now I'm going to remove this old data, Titanic train. The command is rm, and then in the bracket the data name. Now see, it's removed. All right, so this SP, sibling or spouse, is a little bit difficult for me to read it, so that's why I'm going to change the name of this variable to siblings. You can change the name of the siblings, name of the variables by simply putting the rename command. So this is the name of the data you want to save your new data in. Rename is the command, and then in the bracket mydf, this data over here, mydf sibling is the new variable name is equal to the old variable name. Then run this one. So it says renamed one variable siblings. Then check the structure of the data again. All right, so now I can see the survived is integer variable, p class is integer variable, sex is character variable, sibling is integer variable, fair is numeric variable, cabin is a character variable. So let's check what is in these variable. So let's first check the frequency of survived variable. The command is table, and then my data or my df $survived. Okay, so there is 0, 549, and 1 is 342. So it means in Titanic ship, 342 people were survived and 0, they could not survive, they died. Right, out of 891 people, 341 survived and 549 died. All right, and what was their class? Out of 891 passenger, 216 passengers, they belonged to class 1, and 184 passengers, they will belong to class 2, and 491 passengers, they will belong to class 3. So similarly check male and female. So there are 577 male and 314 female. And similarly siblings, so there are 0 to 8, so 0 siblings 608, 1 sibling 209, and so on. And what about fair? So if I go for this variable, fair variable, it will produce too many values over here because it's a numeric variable. So let's check it. See, there are too many values they have produced over here in console window. All right, so let's make these integer variable to factor variable, and the one variable sibling we need it in a numeric variable. So how we can do that? So the command is as.factor. So my df $survived is the name of the variable, then assign it as.factor, my df $survived in the bracket. So this will change the integer variable into a factor variable. So let's run this command, change the p class as well, change the sex variable as well, and then change the sibling variables to numeric variables. The command is as.numeric, and run this one. And that's it. Now we have ready data for bind logic model or logistic model. Remember one thing. So this type of model, we use it if we have dependent variable of dichotomous nature, or in other words, if we have two classification as our dependent variable. For example, 1 and 0, yes or no, pass, fail, by yes, by no, something like that. So if we have two categories in our dependent variable, then binary logic model or logistic regression is the best model to use to predict your odd ratios. All right, the command for model, the command for binary logic model is GLM. So we're going to save our results in model. So you can name it whatever you want to. So let's say I want to save my results in model. Then model GLM survived is my dependent variable. It has classification, two classification like 1 and 0. And then P class, one variable, independent variable, plus second variable, plus third variable, plus four variables. So at this stage, I'm only including these four variables and predicting what will happen if passengers belongs to class 1 or class 2 or class 3, whether they will survive or not. What about sex? Either the male will survive or female survived. I mean, what is the odd ratios of this variable and the rest of the variables with my dependent variable. Okay, and then comma, family is binomial, and then data is my df over here, and just run this command. And here we go. So we have model up there in my environment window. So let's see the results. So here we have the results. So I'm going to interpret the results. Please be careful. All right. So at first line, this one called GLM. This is the command for binary logic model or logistic regression. And then this deviance residual means how our residuals are deviated from the estimated values. So its min and max are somehow close to one another, and mean, median and first Q and three Qs are also close to one another. It seems it has normal distributions. So think about your normal distribution bell-shaped curve. So your residual should be normally distributed. Remember, in my last video, I told you about these things. Over here, it's not too compulsory. Over here, we're gonna work on these are the main results. We're gonna interpret these results. So these are the coefficients, and because this is a log likelihood model, and these coefficients are showing the log odds of your independent variable, and it's gonna interpret the relationship between independent and dependent variable and how. So see in a sec, I'm gonna explain it in a sec. So you also need to look at the p-values. So if the p-value is less than 0.05, it means so your that particular variable is significant at level 95% of confidence interval. All right, so we know that the P class, it has three categories: passenger class 1, 2, and 3. So I can see that 1 is missing over here. So it means 1 is my reference category, and 2 and 3 coefficients are over here. Similarly, sex male is over here, female is missing, so it means the female is my reference category or base category. I'm going to compare this coefficient with female, and then sibling, it was a continuous variable minus 0.2 and fair is 0.003. This is insignificant. The fair is insignificant. The rest of the variables are significant, either on 95% or 90% confidence interval. All right, so P class, it shows negative sign, shows it means less likely. So if you see a negative sign, it means less likely. So P class 2 means the log odds of passengers who belong to class 2 are less likely to survive. Remember our dependent variable was 1 survived and 0 died. So these coefficients will will be based on the survived category. All right, because if you have one as your one category in your dependent variable, then your all coefficients will be interpreted according to that one, and 0 will be your base category. So your interpretation will be like this: if the passengers are class 2, they have minus 0.66 less likely to survive as compared to class 1 passenger. Similarly, class 3 passengers has less likely to survive. How much? Log odds of 1.64. And similarly, male are less likely to survive. If the siblings are more, that people are less likely to survive. The fair is insignificant. If you don't want to explain this variable, it's fine, but it says that the higher the fair, the more likely you will be survived. Okay, so these log odds, these estimates are a little bit confusing because it doesn't make sense if you tell somebody that the log odds of something are this, log odds of something are this. It makes a little bit confusion that the simple person or the layman won't understand what are you trying to say. So what you can do actually, these log odds, if we take exponential of these coefficients, then we will get the odd ratios. So the simple command to getting the odd ratio is you just take the exponential of these coefficients. All right. So first, okay. So for that one is to take the exponential of these coefficients. The command is odd ratios. Here is the name of the variable or the name of the vector variable you want to save. You can name whatever you want to, and then in the bracket exp means exponential, and then model is this model. So in this model, you're going to take coefficients only. So this command says exponential of model from model of coefficients. So if you run this command, here is odd ratios vector variable created. I'm going to tell you in a second that how you can make it as a nice table of these things. So for that one, again, install this package Broom, because I have already installed that one. So I'm going to just load it by library command, library, and the Broom is loaded. First, save your results in model results in results. So this is the name of the table you want to make, or you want to save your results in. So I want to save my results in result, and then tidy model. It will give you a table like this. See? So you just copy this one, just like this. Copy this one. Control C, and then go to over here. Just use the special command. Yeah, C. And cut it, and then paste it over here. Here we go. I'm going to delete this one, and then these are the results. Sorry. So these are the results from binary logic model. So as I said, these are the log odds. So probably you will be interested in odd ratios. Most of the research papers explain the odd ratios. So that's why. So I have just taken the odd ratios by taking the exponential of the coefficients, and I'm going to save these results in result 2, and then tidy odd ratios. See the result too. And here we go. Just copy this one and paste it over here. See, these are the odd ratios. All right, so probably you can put it over here. Better if you only mention odd ratios rather than estimates. You can take one more thing. So see, for example, if you take estimates from directly from the tidy command, and you can calculate the odd ratios over here as well. How? These coefficients are just you just need to take the exponential of these numbers. So exp in Excel is the command for taking the exponential of these coefficients, and then just bring it down and see these are similar with these values. See, these are odd ratios. Odds ratios, not odd ratios, sorry. These are odds ratios. All right, so this is how. So the explanation of odd ratios. What is how we can explain the odd ratios. So if the odd ratio is less than 1, it means the odds of being 1 as your dependent variable was survived as 1 and then died was otherwise 0. So you're gonna use this one, survived as 1. So if the odds are less than 1, you're gonna say that there is less likely chance are there that the people will survive from passenger class 2. Similarly, the odds of class 3 are less likely to survive. Male are less likely to survive, and so if the odds ratios are less than 1, it means you are less likely to be 1. In our case, dependent variable was 1. So in your case, if for example, if you are looking at buying behavior, yes or no, so one is yes, you might say that male are less likely to buy this. All right. So this is how you can explain the results of your odd ratios, results of logistic regression. And that's it for today. Thank you very much for watching today's video. See you in next week.